In the last video we used the integrating factor method to solve a differential equation. Now in this video I'll just do a quick proof of the integrating factor method. So here's our linear first order differential equation. We saw that the integrating factor is got by integrating the coefficient of y with respect to the independent variable x and then taking the exponential. The next step is to multiply the integrating factor by the differential equation. So this is what we get. So we just stick the integrating factor in front of each term. Now we should be able to write the left hand side as the derivative of a product of functions, where one of the functions is this here and the other function is the dependent variable y. Let's see that that's the case. So the left hand side should be the derivative with respect to x of this here, the integrating factor, multiplied by the dependent variable, which is y. This should be equal to the left hand side. Well, we just apply the product rule. So we take the first function, which is the integrating factor, and multiply by the derivative of the second function, that's dy dx. Well, as you can see, that gives us this term here. Then we take the second function, which is y, and multiply it by the derivative of e to the power of the integral of f of x dx. Well, if we differentiate e to the power of something, we just get it back. But by the chain rule, we must differentiate the power. If we differentiate the integral of a function, we just get that function itself. And there we have this second term here. So indeed we can write the left hand side as the derivative of a product. Now let's go on and get a formula. So now we can write our differential equation as the following. Here's the left hand side. The right hand side is just this here. The next step we know is to multiply both sides by dx. We have a y in here. Then we integrate both sides. If we integrate the differential of this thing, we just get what's inside the bracket. Now I will just write down this integral again, and I'll write in the constant. We're going to get a constant of integration from both sides, of course, but we bring them over to the right hand side and just put them together and call it c. Finally, we can get the solution of the differential equation, that's y. So we multiply both sides by e to the minus integral of f of x dx, and that's multiplied by the all of this here. So we have to multiply this exponential by this here, and also by c, of course. So here is a formula that you could use for solving linear first order ordinary differential equations, but in practice you probably won't use this formula. Let's do an example. Let's take this differential equation here. Now we want to get it into the standard form of a linear ODE, so we need to get dy dx on its own, so we need to divide all of this by x squared. If we do that, this is what we get. Now, to get the integrating factor, we look at the coefficient of y, which is 2, and integrate it with respect to x. If we do that, we get 2x. Then we take the exponential of 2x. So the integrating factor is e to the power of 2x. The next step is to multiply the differential equation by the integrating factor. So we just put e to the 2x in front of everything. E to the 2x by e to the minus 2x is e to the 0, which is 1. Now we know we can write the left hand side as the derivative with respect to x of the integrating factor times the dependent variable, which is y. And Then we multiply both sides by dx, integrate both sides. If we integrate the left hand side, we just get what's inside the bracket. If we integrate 1 with respect to x, we get x, and then the constant of integration appears on the right hand side. Finally, we multiply both sides by e to the minus 2x. So now we have our general solution. Now, the equation in part B is identical to the equation in part A, just change of notation.